Hey Precalc kiddos, I am so excited that we are back together again doing some math. Welcome to Distance Learning Day 1. We are going to start in Chapter 12, focusing in on systems of equations, and then that will turn into matrices, which is one of the really fun things that we get to cover in this course. So starting off with Chapter 12, Section 1, we're going to look at systems of equations. And a system is the first word here. A system of equations is a set of two or more equations with two or more variables. So just an example so you kind of know what we're talking about. If we have a 2 by 2 system, an example would be something like 2x plus y equals 5 and x minus y equals 6, okay? This is called a 2 by 2 because there are two equations and two variables. We have x's and y's. We will also study systems that are 3 by 3. So just so you have a visual of what that looks like, a 3 by 3 could be something like x plus y minus z equals 1, 2x minus y plus 3z equals, let's say, 8, and 3x plus 4y minus z is 11. Okay, so this is what a 3 by 3 would look like. Again, it's called a 3 by 3 because there are 1, 2, 3 equations, and there are 1, 2, 3 variables, x's, y's, and z's. When you are finding the solution to a system, typically if it's a 2 by 2, you will have your solution as an ordered pair because you are solving for x and y. If you are solving a 3 by 3, your solution would be written in what's called an ordered triple. So it's your solution, what is the value for x, y, z, again, separated by commas and in parentheses. Now this says a solution to a system of equations is a set of values that satisfies all of the equations in the system. So what that means is if something is a true system, and this is what we're going to try right here, we're going to see if x is really a 2 and y is really a 1. We have to make sure that those two values satisfy all of the equations. Meaning, I go one equation at a time, change the x to a 2, change the y to a negative 1, and make sure that I end up with a true statement. It has to work in all of the equations in order to say that it is a solution. So if I go to the top, 3 times x, x is a 2, plus y is a negative 1, it has to equal 5. Well, 3 times 2 is 6, plus a negative 1. 6 plus a negative 1 is 5. 5 equals 5, so it checks. Okay, so the top equation checks. That's not enough yet to say, hey, it's a solution, because you have to check all of the equations. So now I'm going to go down to the second equation. X is a 2 minus 2 times y, it's a negative 1. That has to equal 4. In math, you multiply before you subtract, and remember a negative sign always goes with whatever's behind it. So when I go to multiply these, this is negative 2 times negative 1. Negative times a negative is going to make that positive. 2 times 1 is 2. Check this out. 2 plus 2 is 4. 4 equals 4, so it checks. So now you can state, yes, this would be the correct solution to that system. Now, this is what the first questions in your book assignment are going to be. They will give you a system of equations. They will give you x and y values, or x, y, and z if it's a 3 by 3. Your job is just to go ahead and verify or check and see, is this a true solution, meaning that it satisfies all the equations. If you fill in those values, every equation ends up being true. Okay, one method of solving systems of equations that have two variables, so we're going to look at x's and y's for now, is to graph both equations and to find the point or points of intersection. Now, if we're looking at linear systems, you would only have one point of intersection because if you graph two lines, the most that they can touch or cross is at one point. Okay, but we're going to go ahead, look at these linear ones. So to do this, go ahead and convert each equation into slope-intercept form. Remember, that's y equals mx plus b. So that's what we'll do first. We will graph by hand, and we are looking for points of intersection. I want y by itself, y equals mx plus b. So if I have 2y equals 3x plus 2, I need y by itself. So I need to divide everything by 2. So y equals, I'm going to keep it as a fraction because remember, this is our slope. This is our rise over run. So if I am graphing this equation, whatever's after x, that's your y-intercept, it's plus 1, so I go up 1. The number in front of x, that is your slope. It's positive, so I go up 1, 2, 3, go to the right 2. Now I can go ahead and connect, and here is that line. Awesome. Okay, now we want to go ahead and graph x plus y equals 6, and you're going to graph that. First, we have to move the equation so it's in y equals mx plus b form. I want to isolate y, so I'm going to take and minus the x. So here I'm starting up 6 because after the x it's a plus 6, so we'll go up 1, 2, 3, 4, 5, 6. Now my slope is negative 1, which is the same as negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Go ahead and connect them. Okay, so these two lines are intersecting. Your solution is where they cross. So they cross at the point 1, 2. You go to the right 2, so your x value is 2. Then I travel up 1, 2, 3, 4. So the solution would be 2, 4. Now, obviously, you're not always going to have nice integers where they cross. So sometimes Desmos.com, that's a really cool place to solve equations. You can get an approximate answer. So I'm going to go ahead and jump on Desmos here to do this. Look at this, 2 iPads. Okay, if I am graphing on Desmos, you do not have to get y all by itself. So if I go 2x minus y equals 1. There is my line. Okay, now the other equation is 3x plus 2y equals 4. Okay, so if I go ahead and I close that so I can see the graphs, what we're looking for, the solution to the system, is the point where they intersect. Now notice this time we don't have integers. We have decimals. So this is an approximation. Desmos doesn't show you a complete value or give you the fraction form. It gives you the rounded decimal. So again, it is an approximation, but your solution here would be 0.857 and 0.714. So those are two examples of how you can solve by graphing. Okay, now we're going to move on. A system of equations may be classified depending on how many or if it even has solutions. If a system has no solutions, it is called inconsistent. An inconsistent solution means that graphically, if you are graphing, those two lines would never cross. So inconsistent occurs when you have parallel lines. Okay, that's how you get no solution. A system that has at least one solution is called consistent. Now there's two things that can happen that are consistent. The lines can intersect, as we saw in our two graphing examples, meaning that they cross and they have one point. Or you might get what's called coinciding lines or the same line. When you graph the first line, you have the line, but then when you go to graph the second one, it lines up perfectly. And in this case, you have an infinite amount of solutions. Any point that is on this line would be a solution. The reason why it's infinite is because lines are never ending. Okay, so inconsistent, there are no solutions. When that happens, it's parallel lines. Consistent means that there is a solution. If they intersect, it would be one solution, the location where the two graphs do cross. Or if you end up with the same line, then it's an infinite amount of solutions because lines are infinite and any point on that line would be considered a solution. All right, let's keep going. Solving systems of equations by graphing, it's helpful, but you got to keep in mind that it gives you approximate solutions. When you graph by hand, sometimes it's difficult to figure out exactly where it crosses. If you're using Desmos, you're getting those rounded solutions. If you want exact solutions, meaning keep it as a fraction, okay, you want that exact solution, you want to use algebra to solve your systems. And when we're doing that, there's two methods we're going to look at. The first one is called substitution, and the second method is called elimination. Wanted you guys to feel more at home, so we'll have announcements during the notes. Sue Volkman had to go to the office. Okay, so we're going to keep going. We have substitution and elimination. The first two examples we'll look at is the substitution method. When they ask you to do the substitution method, the first thing you have to do is you have to have one equation solved for a variable. So you need one of the equations to say y equals or x equals. So if I am looking at this example, I don't have a variable by itself, so I need to create that. The easiest variable to isolate is the one that does not have a number in front of it. So in this case, this y. So I'm going to go ahead and take this 3x and minus it to the other side. So I would have negative y. I minus the 3x, the 12 stayed where it is, so it is still positive. Y is not alone. This is negative 1 times y. So I need to divide everything by negative 1. So y equals negative divided by a negative is a positive 3x. Positive 12 divided by a negative 1 is a negative 12. This is your new equation. So I will no longer use this equation because in the substitution method, the first step is one equation. You have to have it solved for either x or y. So y equals 3x minus 12. Now the reason why it's called substitution is because I'm going to go ahead and substitute in what y is equal to into the other equation where y is. So I have 2x plus 3, but instead of y, I substitute y's value. 3x minus 12, and it equals 2. So everything here stayed the same except for y. The 2x is still there. The plus 3 is still there. Y, I substituted in the value for y. It's still equal to 2. Now if you notice, my problem only has x's, so I can solve for x. Distribute the 3 into the parentheses, so I would have 2x plus 9x minus 36 equals 2. Combine like terms. 2x plus 9x makes 11x minus 36 equals 2. Add that 36 over, and I'm going to travel on over to this side, so I would have 11x equals 38. Divide both sides by 11, and x is 38 over 11. Okay, so now I have the x value. What I need to do is find the y value, because remember what you're looking for is if you graph this system of equations on a coordinate plane, what is the ordered pair where you're going to see those two lines intersect? So I have the x value, now I need to find the y value. I have to go ahead and plug the x value into the equation that says y equals, because I want to know what y equals. Y equals 3 times x. X is 38 over 11 minus 12. So again, I kept the y the same, the equals, the 3, the minus 12. X became 38 over 11. Here we're multiplying fractions. When you multiply fractions, it's top times top, bottom times bottom. So y is 3 times 38 is 114 over 1 times 11 is 11 minus 12. Now they want us to subtract fractions. You can't subtract fractions without a common denominator. So I need to multiply this, the top and the bottom, to create a fraction with a common denominator of 11. So y is 114 over 11 minus 132 over 11. Now that you have a common denominator, that carries over. 114 minus 132 is negative 18. So here are your two values for your variables. Okay, so x is 38 over 11, y is negative 18 over 11. You write your final solution as an ordered pair because it's representing a location on a coordinate plane. So you would be going to the right 38 elevenths, and you'd be traveling down 18 elevenths, and that's the location where those two lines would intersect. Okay, let's do another one. And they are going to give you crazy fractions, guys, because this is an upper level math class. You're not going to have nice solutions like 2, 1. You're going to get the crazy fractions, okay? Let's do another one. So if I am doing substitution, step 1, you need to have one equation solved for either x or y. So again, they did not set us up with that right away. So I need to get a letter by itself. Y does not have a number in the front, so I can easily isolate that. I'm going to go ahead and minus my 2x to the other side. So y equals, the 2x was positive here. When I move it now, it's a negative 2x plus 2. So I will no longer use that equation. This is the new equation that I will use because it follows the rule for substitution. I have y by itself. So now I substitute negative 2x plus 2 in for y in the other equation. So 3x minus 2. Instead of y, you substitute in negative 2x plus 2. It's equal to 4. Now if you notice this, it's kind of cool. I only have x's, so I know that I'll be able to solve for x. I have to eliminate the parentheses by distributing. A negative sign always goes with whatever's behind it. So when I bring this in, this is a negative 2 that you're multiplying in. So 3x, negative 2 times negative 2x is positive 4x. Negative 2 times positive 2 is negative 4 equals 4. Combine the like terms. So 3x plus 4x makes 7x, minus 4 equals 4. Now we have a two-step equation. Add 4. So 7x would equal 8. Divide both sides by 7. X is 8 over 7. But again, you're not quite done yet. This just tells you on the coordinate plane to find the point of intersection, I would go to the right because this is positive 8/7. But I don't know how high or how low to go. So I need to substitute this value, 8 over 7, into the equation that says y equals, because that's the value I need to find at this point. So I need to change x into 8 over 7, and then I can find y. Y equals negative 2. X is 8 over 7 plus 2. Again, we're multiplying fractions, so it's top times top, bottom times bottom. Y is negative 16 over 7 plus 2. You cannot add fractions unless you have a common denominator. So I need to multiply top and bottom by 7. So y equals negative 16 over 7 plus 14 over 7. When you're adding fractions and you have a common denominator, the common denominator stays. What you're adding are the numerators. Negative 16 plus 14 is negative 2. Now I know what x is, I know what y is. You can write your ordered pair. So you would go to the right 8/7. You would go down 2/7. That is your solution. That's the point of intersection. So there are two examples of the substitution method. Okay, now we're going to go ahead and look at elimination. Now everybody kind of has their favorite when it comes to substitution and elimination. Personally, for me, I love elimination. It says to solve using the elimination method, first, you need to have opposites in front of your variables. So when you look at the two equations, you're going to have to be able to look either in front of x or y or z when we get to our 3x3s. And when you add them, you want to be able to completely eliminate that variable. In order to do that, you have to have opposites, meaning it's the same number, but one is positive, one is negative. Okay, so let's say, here's my first one. I have x minus 3y equals 4, 2x plus y equals 1. Let's say I want to eliminate the y's, okay? In front of this y is negative 3. In front of this y is a 1. I need this to become a positive 3. So I need to multiply every single term in the second equation by 3. The top is staying. X minus 3y equals 4. The bottom, 3 times 2x is 6x, plus 3 times 1y is 3y. 3 times 1 is 3. Now when you add them together, negative 3y plus 3y, it is eliminated. 1x plus 6x is 7x. 3 plus 4 is 7. Hey, they gave us a nice one. 7 divided by 7, x is 1. Okay, so again, you have an x value. We need an ordered pair for the solution. So when you're doing elimination, once you have one solution, you go back to your original system. You can pick whichever equation you want, and you're going to substitute in or replace the x with a value of 1. It doesn't matter which equation you select as long as you mathematically do everything correct, you'll end up with the same answer. So I'm going to go ahead and pick the bottom equation. So it's 2 times x, but we just found x to be a 1, plus y equals 1. Well, 2 times 1 is 2, plus y equals 1. If I minus 2 over, 1 minus 2 is negative 1. So I have x, I have y. There is my solution. That is the elimination method. Let's do one more. Now here they're trying to be really tricky, guys. Check this out. So 2y equals 3x plus 2 and x plus y equals 6. Well, in order to do the elimination method, you have to line up your variables. So here I have x on this side and x is on the other side. The y's aren't lined up. So your first step here, I'm going to have to take that 3x and move it to the other side. Because it's positive on this side, when I move it here, it becomes negative. Negative 3x plus 2y equals 2. X plus y equals 6. Now this is a format where I can go ahead and do the elimination method because my x's and my y's are lined up and they're on the same side of the equation. Okay, this time let's say I want to eliminate x. Okay, if I want to eliminate x, this is a negative 3x, this is a 1x. If I multiply all of these terms by 3, I would have opposites in front of x. So I'm keeping the top the same, not changing anything. The bottom, 3 times x is 3x. 3 times y is 3y. 3 times 6 is 18. When I add them together, check that out. The x's are eliminated, and that's why it's called the elimination method. 2y plus 3y is 5y. 2 plus 18 is 20. Go ahead and divide both sides by 5. 20 divided by 5 is 4. So I do have one solution. When you have one solution, go back to the original system. Change the y to a 4 in one of the equations and solve for x. So I'm going to go to the bottom equation. X plus y is really a 4. That has to equal 6. If I minus 4 to each side, 6 minus 4 is 2. So I have my x, I have my y. I can go ahead and write my solution. The solution is the ordered pair, 2, 4. Okay, so far we've covered we've covered 3 methods for how to solve systems of equations. We graphed both by hand and by Desmos. We did the substitution method, and we did the elimination method. One thing that we haven't covered is, well, what happens if you end up with an infinite amount of solutions? Or what happens if it's no solution? So just being able to tell when things are inconsistent or consistent. Okay, so here are 2 examples where that's going to happen, okay? Let's say I want to do the elimination method, and I want to cancel my x's. This is a positive 2x, this is a positive 4x. Well, if I multiply the whole top by negative 2, negative 2 times 2, this will give me a negative 4x. But again, that negative 2 has to go to everything. Negative 2 times negative 3y is positive 6y. Negative 2 times positive 5 is negative 10. So that is my new top equation. The bottom, I am keeping the same because what I wanted to do here is eliminate the x's. Those eliminate. Whoa! The y's also eliminate. If everything eliminates, this side is a 0. There's nothing left. Okay, so 0, negative 10 plus 1 is negative 9. So we have a scenario that says, hey, 0 is equal to negative 9. Well, when does 0 equal negative 9? Never. So these lines are parallel because they are the type of lines that never touch. So again, these 2 solutions are never equal. That means your lines never touch, so they are parallel. If they are parallel, it is inconsistent, meaning there's no solution. Okay, let's look at another one similar to that. Again, let's say I want to cancel the x's. I need to create opposites. This is a 2, this is a negative 3. So I have one positive, one negative, so that's awesome. I need these to be the same number. So if I multiply the whole top by 3 and the whole bottom by 2, the top would have a positive 6x and the bottom would have a negative 6x. So I'm going to go ahead and do that. So the top becomes 6x minus 12y equals 18. Now the bottom, when I multiply everything by 2, negative 6x plus 12y equals negative 18. When I add them together, boom, boom, hey, everything on that side is gone, so it's a 0. Negative 18 combined with the positive 18 is also 0. When does 0 equal 0? Always. So these are lines that always touch, meaning it's actually the same line. Again, these two values are always the same. So your lines always touch graphically, meaning that you have coinciding lines. They're the same line. So you have an infinite amount of solutions because lines are infinite, and any point that would fall on that line would be a solution. So guys, this is the beginning of 12.1. I know the notes were a little bit lengthy today, so today was kind of just a day to see, hey, what are we studying? What are the different methods? Tomorrow, your only assignment is to go ahead and practice these different concepts. So the assignment is 1 to 4. Jump ahead, go 7 to 10, 15 to 22. It's in your textbook on 788. You will be handing these in still for notebook checks, so please put it on paper that you can rip out and get back to me. I hope you enjoyed being back together again and doing some math. I miss you guys so much. I hope you are all doing well, and I will talk to you soon. Bye.